Fractions and simplifying fractions. A prime number is a natural number other than 1 whose only factors are 1 and itself. Here's an example of a few prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and the list does continue. Now, composite numbers are also a natural number other than 1, but these are values that are not prime numbers. Prime factorization, the process of writing a number as a product of primes. Notice the word product. Product really means multiplication. So to find the prime factorization, it really means the process of writing a number in terms of multiplication of primes. Now, I will commonly refer to prime factorization as factor trees. But what's different about prime factorization is really what you're doing is you're finding the unique DNA of a particular number. So let's look at 63. If I were to do the prime factorization for 63, I need to think of two numbers that multiply to give me 63. Most common would be 9 and 7. Looking at 9, is 9 prime or can it factor? Well, 9 is made up of 3 and 3. Well, 3 happens to be a prime number, so I circle it and call it a berry on my factor tree. The next branch I see is a 3, and 3 is also prime, so I circle it and it becomes another berry. The last branch I see is a 7. 7 is also a prime number, so I circle it and I have another berry. So since all I have are berries and no more branches, that means my prime factorization is done. 63 is really the same thing as 3 times 3 times 7. Let's look at 40. Think of two numbers that multiply to give you 40. Maybe you're thinking of 4 and 10. Well, can 4 factor or is it prime? Well, 4 is actually made up of 2 and 2. Looking at the first branch of a 2, notice 2 is a prime number, so we circle it and turn it into a berry. The next 2 is also prime, so we circle it as well. The other branch we have is a 10. Now 10 can factor into two values of a 2 and a 5. Again, 2 is prime, so we circle it, and it turns out 5 is prime as well, so it too is circled. So notice all we have are our berries, so we're ready to write 40 in terms of prime factorization. 40 is really the same thing as 2 times 2 times 2 times 5. But what if you didn't choose 4 and 10? What if you chose different values? Would that change your prime factorization? Well, let's see. What if you chose the values 8 and 5 instead? Well, 8 can factor, and it gives you 4 and 2. 4 factors and gives you 2 and 2. Notice 2 is prime. The other 2 is prime. The other branch of 2 is prime. And the last branch of 5 is prime. So notice we have no more branches, we have all berries. So we can rewrite 40 in terms of its berries, which is 2 times 2 times 2 times 5. Now, although we factored the two values differently, look at the results. They're the same, which means it doesn't matter what numbers you start out with to factor it, the prime factorization will always be the same. It is unique to that number. So here's a couple of try it problems. For A, try to do the prime factorization for 36. For B, do the prime factorization for 200. For A, I hope you found 2 times 2 times 3 times 3. Again, the order is not important. Just make sure you have those factors. And for B, I hope you found 2 times 2 times 2 times 5 times 5. How to simplify fractions. We're going to look at 4 easy steps. The first step, factor the numerator, or the top number, and factor the denominator, the bottom number. Step 2, rewrite the fraction in factored form using your factor trees. Step 3, find common factors that appear in the numerator and the denominator and reduce the values to a value of 1. Step 4, simplify the fraction. Example 1, simplify. For A, we have the fraction 42 over 49. So step 1 was to factor the numerator and factor the denominator. So I'm going to give you a moment now to factor 42 using the factor tree and use the factor tree for 49. For 42, I hope you found the factors of 2, 3, and 7. For 49, I hope you found the factors of 7 and 7. So step 1 is to simply do factor trees. Step 2 is to write your fraction in factored form. Well, in the top, the numerator, we found 42 to be made up of 2 times 3 times 7. And in the denominator, we found 49 to be made up of 7 times 7. So step 2 is to simply rewrite the fraction. Step 3 is to look for common factors that appear in the numerator and the denominator. Do you see anything that appears in both the top and the bottom of the fraction? Notice there is a 7. So because it appears in the top and the bottom, both of those values reduce to a value of 1. Is there anything else that's common in the top and the bottom? No. So the last step is to simplify your fraction, which means in the top, in the numerator, we have 2 times 3, which we know is 6. And in the bottom, we have 7 times 1. So your final answer is 6 over 7. Let's try another one. For B, we have the fraction 88 over 20. Take a moment now to do your factor trees for 88 and 20. Take a moment now to look at my factor trees and make sure you have the same prime factors. So step 1 is to do factor trees. Step 2 is now we bring all the factors into the fraction form. In the numerator, you should have 2 times 2 times 2 times 11. In the denominator, you should have 2 times 2 times 5. Now, in order to reduce this, we look for common factors that appear in the top and the bottom. Notice we have a pair of 2's. We have another pair of 2's. Is there anything else? No. So the last thing we need to do is to simplify our fraction. In the top, we have 2 times 11, and in the bottom, we have 5 times 1. So your final simplified answer is 22 over 5. For C, we have the fraction 7 over 25. Take a moment now to do factor trees for 7 and 25. Now notice 7 is a prime number, so it remains a 7, but 25 we know is made up of 5 times 5. So now we look to see if there's any common factors that appear in the top and the bottom. Since they have nothing in common, that means this fraction cannot reduce, and so your simplified answer will remain 7 over 25. For D, we have the fraction 18 over 90. Take a moment now to factor the 18 and the 90. Now we need to rewrite the fraction. In the numerator, you should have a 2 times 3 times 3. In the denominator, you should have 2 times 3 times 3 times 5. Again, don't worry about the order, you just need the values in the correct location. So now looking at the top and the bottom, are there any values that appear in both places? Notice we have 2's, we have 3's, and we have another set of 3's. So now that we've reduced it, let's see what we are left with. In the numerator, you have 1 times 1 times 1, which gives us 1. And in the bottom, you still have that 5. So your final answer is 1/5. Here are your try it problems. Number 1, 64 over 12. Number 2, 63 over 72. Let's see how you did. For number 1, it should have reduced to the fraction of 16 over 3. For number 2, it should reduce to the fraction of 7 over 8.